Welcome to this session on problem solving in asymmetric synthesis. Let us look into our first problem. Predict the major product in the following reaction. Let me take up the molecule. So as I work out the problem, you also can draw it in your notebook so that it will be easy for you to follow the steps. I have my molecule, my carbonyl compound. So we are trying to apply the Cram's rule and the Felkinan modification to compounds which has a prochiral carbon, and also a chiral carbon. So according to Cram's rule, we know that we need to draw our molecule in the desired conformation, and after that we have to perform the addition reaction. So the reaction conditions are, you're using lithium aluminum hydride and diethyl ether at 35 degrees Celsius. Okay. So what is the product? Now, when we try to solve this problem, the first thing that we need to remember is we need to draw our structure or the conformation according to Cram's rule. So I'm drawing the structure according to Cram's rule. See, I'm actually drawing the structure in such a way that I view my molecule from this side. So when I view my molecule from this side, I will have my carbonyl oxygen at the top, tertiary butyl group at the bottom, and I will have my methyl group on my left hand side, my hydrogen in my right hand side, and then I will have my phenyl group. That's right. Okay. Now, what happens here? According to Cram's rule, when my carbonyl group is flanked between the medium and the small group, my nucleophile prefers to attack from the side of the smaller group. That leads to this product. So when hydride attacks the carbonyl carbon, my oxygen will be moved towards this side, so resulting in the formation of OH. The incoming nucleophile will be here, which is hydrogen. I have my tertiary butyl group at the bottom, and I am making no change to my molecule where I have my asymmetric carbon. So I have my methyl here, I have my hydrogen here, and I have my phenyl here. Now in this molecule you can see my OH group is cis to my methyl, my hydrogen is cis to my hydrogen, and my phenyl is cis to my butyl. So how to draw or how to convert this Newman projection into a sawhorse form? So when I try to convert this Newman projection into a sawhorse form, I end up with a structure like this. I'm going to view the molecule from the chiral carbon side, and I will have my hydrogen here, I will have my methyl group here, I have my phenyl here, and on my other carbon I have my hydrogen here, I have my OH group here, and I have my tertiary butyl here. Okay, so you can see I've actually rotated this molecule. Say I had rotated towards my right in an anti-clockwise direction. So when I rotate the molecule, I get this view of, or I get this view actually. So it's an equivalent structure. Now you can see my OH and methyl are eclipsing each other. My hydrides are eclipsing each other, and my tertiary butyl and phenyl are eclipsing each other. Now, what I do, I see we have just applied Cram's rule into this problem. Now let me add Felkinand model to this problem, because you can see here we have two bulky groups, and when there are two bulky groups eclipsing each other in a Cram's model, the relative conformation will not be stable, and that is where Felkinand modification comes into picture. So according to Felkinand modification, I have to put my phenyl group perpendicular to my carbonyl-carbon. So let me draw this first. Okay, so butyl. Now I have two possible conformation. So by my most stable conformation in this case would be now here I have drawn the most stable conformation. So what I have done is I have just rotated this phenyl group to this side, so my methyl group comes to the top. Okay, so it comes to the top, and my hydrogen goes here. Now what we are trying to do here is we will try to do the addition from the side of the smaller group. So when I add hydrogen, I end up with this structure. Sorry. I have my OH group here. I have my hydrogen here. I have my tertiary butyl group here. And there is no change in the chiral carbon. I have my phenyl, I have my methyl, and I have my hydrogen. Now, how to correlate these two structures? Okay. Now, I will draw another structure. What I will do, I am going to do a 60-degree rotation, and I am going to make it as an eclipsed form. So when I do that, let me draw a chiral carbon first. I have my phenyl here. I have my methyl here. I have my hydrogen here. So I will be having the three groups here. So this will be my tertiary butyl group. So when I rotate this, my tertiary butyl group will be eclipsing my phenyl, and my OH hydroxyl group will be eclipsing my methyl. My hydrogen will be eclipsing my hydrogen. Now, if we could compare these two structures, oh my god, just compare these two structures. So I have my phenyl and tertiary butyl eclipsing each other, yes. I have my methyl and OH eclipsing each other, yes. I have my hydrogen and hydrogen eclipsing each other. Therefore, these two structures are same. So you get the same product when you apply the Cram's model and also the Felkin and model. So this is how we need to proceed whenever we get a problem using Cram's rule. Thank you for watching.